Hey ladies and gentlemen, this is Miss Humbert here. Today we're going to be doing Unit 7, Note 6. So we're going to be talking about inscribed angles. So let's go ahead and let's take a look at what an inscribed angle is. So when we're talking about inscribed angles, it's angles that have the vertex on the circle. So you notice the vertex of this angle R is actually on the circle itself. Okay? And the sides of it are chords of the circle. So RQ is a chord and RS is a chord. So notice that all points of this angle are on the outside of the circle. There's nothing dealing with the center right now. So that means that angle QRS is an inscribed angle. Along with inscribed angles, there is an intercepted arc. And an intercepted arc is an arc with endpoints on the sides of the inscribed angle that lie on the interior of the inscribed angle. So that means that QS, this intercepted arc right here, that is an intercepted arc. So angle QRS has an intercepted arc of QS, and that's basically because the endpoints of our vertex are at Q and S. That's what makes it. It's being swallowed up kind of by that angle. So let's go ahead and let's remember what we previously learned. We learned about a central angle. So central angles have the vertex at the center. So the vertex is at the center. So here's the center of our circle, and then we had our vertex at it, and then our angle going out. Well, if this was x degrees, then the degree measure of our arc was also x degrees of the circle. Now, that's not true for inscribed angles. That's different here. So if the angle is an inscribed circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So what does that mean? So to find the measure of angle 1, we need to take 1/2 the measure of our arc AB. Okay, so whatever this degree measure is, we take 1/2 of it, and that will give us the measure of our inscribed angle. So let's go ahead and let's put that to practice a little bit. So we want to find the measure of angle P. Well, here's angle P right here. So I notice that I know the intercepted arc length, that is 70 degrees. So now I'm taking that 70 degrees and I need to divide it by 2 in order to get the measure of that angle there, because that is our inscribed angle. Well, 70 divided by 2 is 35 degrees. So then we want to take a look at the measure of angle P, or the arc length PQ. So here's our arc length PQ. Now I notice that it's being contained by the angle N here. Well, angle N is 56 degrees. So to go from the inscribed angle to get the arc length, we're going to take the number of degrees and multiply it by 2 to get that arc length. So 56 times 2 is 112 degrees. Next, let's take a look. We want to find the measure of angle C. Well, let's figure out where angle C is. Angle C is right here. I notice that the intercepted arc is DE, and the intercepted arc length is 98 degrees, not the band, just the degree measure. So now we're going to take that 98 and divide it by 2. 98 divided by 2 is 49 degrees. Okay, so our inscribed angle length then is 49 degrees. Next, let's take a look. We want to find the arc length CF. So whenever it asks me for an arc length, I see if I can find an inscribed angle that's associated with it. So I notice that angle D is an inscribed angle to the arc CF. And I notice that it has an inscribed angle of 40 degrees. So to get the arc length, I take the degree measure, multiply it by 2. So that means that arc length is 80 degrees. Okay? Let's take a look at number 5. So for number 5, before we get to number 5, we need to learn a new theorem. If two inscribed angles of a circle intercept the same arc or are congruent arc lengths, then the angles are congruent. So let's take a look at an example. So I'm going to start by having an angle C. An angle C is going to intercept the other side at points A and points D. So that's where the arc is intercepting the other circle. And then I'm going to have another angle that I'm going to call angle B. So angle B is going to have a different vertex, but angle B is going to connect at the same points. So what I know right now is angle B and angle C both intercept, or both have the intercepting arc of AD. Intercept arc AD. So what does that tell us? Well, that tells us then that the measure of angle B is congruent to the measure of angle C. Okay, so that's the next theorem that we're working on. So let's take a look at number 5. So for number 5, we want to find the measure of angle t. Well, let's see here. We have an angle here. That's the measure of angle t. I notice that its intercepting arc is SV. Well, then we look at u, and I notice that its intercepting arc is also SV. So that means I can take 3x minus 5 and set it equal to 2x plus 15. So now I'm going to go ahead and solve for x. I have a smaller amount of x's on this side, so I'm going to go ahead and subtract 2x from both sides. Then I get x minus 5 is equal to 15. Now I need to finish solving this for x, so I'm going to add 5 to both sides, and I get that x is equal to 20. So that's not what the question is asking though. The question wants us to find the value of the angle of t. So I need to plug in 20 for my x there. So the measure of angle t is equal to 3 times 20 and then minus 5. So you can punch that right into your calculator, and when you do that, you end up getting 55 degrees for the measure of angle t. Next, let's take a look at number 6. So now it's telling us that SV, or an angle S, is 3x. So that angle right there is 3x. Then the measure of angle V right here is x plus 16. So I notice that they both have an intersecting arc of TU, which means the angles need to be congruent. So then 3x is equal to x plus 16. So I'm going to start by subtracting x from both sides, and I get 2x is equal to 16. Then I'm going to divide both sides by 2, and I get that x is equal to 8. Again, not what the problem is asking. The problem wants us to find now what the measure of angle S is. So I need to plug in 8 right there. So I have 3 times 8 is equal to 24 degrees. So the measure of angle S is 24 degrees, and that's actually also the measure of angle V as well. Let's take a look at our next theorem here. An inscribed angle of a triangle intercepts the diameter or semicircle if and only if the angle is a right angle. So let's take a look at the measure of angle G. So I notice angle G spans the diameter FH, which means that the intercepting arc of my angle G is a semicircle, and semicircles are 180 degrees. So if the arc FJH is a semicircle, which it is, as we can see, because it spans the diameter. So then that means that the semicircle is 180 degrees, the intercepting arc is 180 degrees. Then angle G is equal to 1/2 of 180, or 90. So this right here is a right angle. So you'll notice now that here I have a right triangle. So you're going to be using those right triangle properties to apply algebra and so forth with circles. So let's take a look at an example with a right triangle. So find the measure of angle F. Well, first of all, what do I know about the measure of angle G? Well, angle G, its intercepting arc is a semicircle, so angle G has to be a right angle. So now I want to think back to what I remember about triangles. Well, triangles have to be right angles. So 4x plus 2 plus 9x minus 3 plus 90 needs to be equal to 180 degrees. So now let's go ahead and solve this. So 4x plus 9x is 13x. 2 minus 3 plus 90 is going to give me 89, and that's going to be equal to 180 degrees. So now I need to subtract 89 from both sides, and I get 13x is equal to 91. Last but not least, I want to divide both sides by 13, and then I end up getting that x is equal to 17. Well, that's not what our problem asks. Our problem asks, what is the degree measure of angle F? Well, now that we know what x is, we can plug in 17 for that. So we get 4 times 17 plus 2. And that's going to be our angle measure of F. So 4 times 17 plus 2, and we get 70 degrees for the angle measure of F. Let's take a look at our last theorem here. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Now, supplementary, remember, that means equals 180. So that means that angle K plus angle M are equal to 180. Likewise, angle L plus angle N are equal to 180. Okay, so that's all that theorem says, is that the opposite angles are congruent. So let's take a look at number 10. So for number 10, I want to find the measure of angle A and B. Well, I can very easily figure out the measure of angle B here. So the measure of angle A is even easier. So I notice that angle C has a measure of 90 degrees because of that square. Well, if C is 90 degrees, then we need to do 180 minus 90. Well, that's 90 degrees. So the measure of angle A then is 90 degrees. Now we want to find the measure of angle B. So that means 2x minus 30 plus x, that needs to add up to 180. So 2x minus 30 plus x needs to add up to 180. So then we have 3x minus 30 is equal to 180. Then we add 30 to both sides. And I end up getting 3x is equal to 210. Divide both sides by 3, and then we get that x is equal to 70. So x and 70 are the same thing. So what I'm going to do to get the measure of angle B is I'm going to substitute that x out, and I'm going to put in that 70 instead. So I have 2 times 70 minus 30. So then when you plug that into your calculator, you end up getting 110 degrees for the measure of angle B. Next, let's take a look at this one. So we want to find the measure of angle X and Y. Well, the opposite angle from Y is W. So I'm going to call angle Y X. So X plus 95 needs to add up to 180 degrees. So now I'm going to go ahead and I'm going to subtract 95 from both sides. So then when I subtract 95 from both sides, I end up getting that X is equal to 85 degrees. So that's for the measure of angle Y. So the measure of angle Y is equal to 85 degrees. So now that I solved this one, now I want to know what the measure of angle X is. So now this is going to be my variable, and the opposite angle is 60. So now we have X plus 60 is equal to 180 degrees. So now I'm going to subtract 60 from both sides, and I get that X is equal to 120 degrees. So the measure of angle X is 120 degrees. So that's your final answer for number 11, and that concludes your note sheet today. So go ahead and show me completed note sheet when you're done. Thank you.